Okay, let's get started. So these were interesting 2 days on my part. So midterm 2s are graded, they're up here. Feel free to pick them up if you haven't. Please pick them up because I don't want to have to keep carrying them. So you may notice that the grades for midterm 2 are a lot lower than those for midterm 1. So I'm going to go over the sample solutions, but 2 things. One, remember that the final exam, if you do better on it, will replace your lower midterm grades. So think of midterm 1 and 2 as warnings if you didn't do well on them. If you did well, I wouldn't worry about it that much. If you didn't do well on them, like you left several questions blank or got very low scores on questions, then what I would recommend you do is to understand why you missed the points. Because the final exam can redeem yourself. You can redeem yourself entirely on the final exam. So this is not a set in stone thing. But I urge you to actually understand why you missed points. Not just that you missed points and then like you're gonna do amazing on the final. Because if you just ignore what you've missed, then you may repeat yourself by missing points on the final. It's okay to miss points once. It's a really bad thing to miss points twice or more. Okay? And what was the other thing I was going to say? I'll try to remember it. Okay, so here are the sample solutions. For each of the questions, several people did get full points on some of the questions, but very many people lost a lot of points because what I've seen is that there's a fundamental lack of understanding of the basic concept. So like for here, what does it say in the first 4 words of the directions? To create the following functions. So do you think a lot of people didn't write functions? Yeah, so when it says functions, I expect functions, okay? For all parameters, you can assume the types of each are int. So do you think I saw several people write like string as the parameter type? So look at the directions when you see something like this. It tells you what I'm expecting. I'm expecting a function with parameter types that have ints in them, unless otherwise. So like for the first one, it says take parameters by reference, and I put them in italics. That's what I'm expecting to see, by reference. A lot of people didn't use references at all, just wrote int or something else entirely. I don't really care that much about the code on the inside. It's writing the function that's important here, because the first 4 words are creating functions, okay? So in this case, I did ascending. Actually, this is wrong. What order is this code?
That would be descending.
Descending, yeah. That was my bad. So I'll change that. That should be descending order. You can do ascending, descending, doesn't matter. I don't care about that. Num called, I think only like 2 or 3 people got this question. So the key idea is to use static, because remember, when you call this function, if you have an integer that's set to 0 on the inside and it's not static, every time you call the function, it's going to be set back to 0 because it's not static. What does static mean for those who remember? What does static mean?
It initializes it once when the function is called
Right.
the first time, and it doesn't delete the value.
Right. So there's exactly 1 copy of x. No matter how many times I call num called, there's exactly 1 copy of x, and it's not set back to 0 every time. It's only set to 0 the first time I call this function. So I just add 1 to it. So this first line will only be done once. This will increment it by 1, and then we return the value. So the idea there was to use static. I wanted to put static on the test somewhere, and that's where I put it. All diff, so The reason I put this function on here is because it's extremely important to me. So in my research, I use this function so much. Like in some of my simulations, I literally call this function billions of times with a B. So I've spent months trying to find the fastest implementation of all diff. So being able to write a simple version of all diff I thought was actually pretty important. So take a vector of integers here and just determine, are there any duplicates at all? So we kind of did some examples in class related to this. Not this exact example, but related. So the idea here is if there is a duplicate somewhere, then some index I and some other index j have the same value. So would it be enough to say, well, if they have the same index, then there's a duplicate? No. So if they have the same index, what can I guarantee about the vector? Does it have duplicates? If I just look at the exact same index? No, I can't tell anything because the value at index I is equal to the value at index I. Okay? So here, a lot of people said, who did this almost perfectly, said put 0 here for j. But if you set I and j equal to 0, then you're looking at the same index. So here, you just set it to I plus 1, so you guarantee that they're never the same index. And if I check one pair, I don't need to check it the other way around. So yeah, you can just put it to I plus 1 there. So then I just check if they're equal at all. If index I is equal to the thing at index j, then they're not all different, so I return false. And then, but if I put an else right here after this if statement that this pair I and j are not equal, and I put else return true, is that the right thing to do? So if I look at this pair, they're different. Does that tell me that the rest of the vector is all different? No, just this one pair is different. So you can't just say right here, put an else and say return true, because then it'll only check one pair of values. And you want to check all pairs. Any questions on the first three? Okay, and actually for B, the thing that is in bold, I saw people do that. So it says you may not use global variables for this function. So when I see that you use a global variable, what do you think I'm thinking? Frustration. So yeah, read the directions. I bold and italicize the things I think are important. So, or more important. So just be careful about that. For the extra credit, I was actually surprised that some people actually did get it. I was very pleased about that. So the idea here is for A up here, where you're printing in sorted order, and you can't modify the array, or even create new arrays. So the idea is find the minimum element in the array wherever it is, just search through it, then print the number of times that element appears. So you're printing the smallest value, however many times it appears, then find the next value in the array that's larger than that smallest value and print how many times it appears. And then etc. until you've exhausted the list. So that's basically how you would do that. So the key of this question is, what if you were not allowed to modify the array in advance? So like if it was passed to you by const reference or something, and you can't modify the array at all. So you can't use any sorting algorithms on it. So how would you actually do some of the operations we want, like getting the values in sorted order? So thinking about questions like that is important. Okay, question 2. This was very not well done, like probably the worst of all the 5 questions. So, so it says create any necessary code. A lot of people didn't write code, okay? So when it says create code, what do you think I'm expecting? Code, okay? And the hint here is there's a class word right here. So what do you think I'm expecting? Class. How many people didn't write a class? A lot. So please, please read the directions. They're there to help you along. I'm not trying to trick you here. The word, it's there to help you. So look here. So where's the word, even ignoring the directions, just looking at the code here, what thing would make you suspect that you need to create a class? Where? Course. Course. Is course a type that we've seen in the standard library? No, so I'm expecting you to write a class called course. So, yeah, you don't need to use an include guard, but you need to create a class here. It says, well, look at this first line. How many constructors should you make? 2, or 1 if you're clever, but 2. What does C1 correspond to? Default constructor, so I'm expecting a default constructor. What about this one? It's supposed to pass a string. So a different constructor which takes in a string as its argument. Okay, what does this second line have you believe? There's a function called setName. What do you think the return type should be? Void. Why?
Because you're assigning a value, not returning a value.
Well, yeah, but am I assigning something in this statement?
Not in the statement.
No, not there, but so that would lead you to believe that it's void, but why is it called setName? What does that tell you?
It's a setter.
That it's a setter, and what does setters have their return type be? Void. So I'm expecting a void function called setName. What should the function take it as its parameter type? A string. And then it sets the, so this tells you what should I have as an internal data member. You should have a string as a data member, at least. Okay, so we have a vector of strings right here. And then here we have a different function. So add students is a different function. What should its return type be, do you think? That one should be void because it's not assigning anything here. So it's probably void. So this is not a complete example. So you could, in principle, make it something returned, but void is the intended solution. What should it take as its parameter type? A vector of strings. I saw some people write vector of ints. It's vector of strings because students was passed into it. And students type is vector of string. Okay, so that should be a void type. There's no function to say, I have a vector and I want to push back a whole vector. You have to loop over the passed in vector and add each individual string via pushback. It doesn't say you have to use pushback here, but that's the intended way to do it. What is get students supposed to return, do you think?
That's supposed to return the
Vector of strings. And you see that it's used in what type of loop here? A range-based for loop. So it's returning something that you can loop over. So a vector of strings or a string array. So I was expecting vector of string there. And it's supposed to return the internal student's vector. So that's another data member you're supposed to have, vector of string. What should num students return? What type? An integer, number of students. You could technically return 0, and some people did that. That's fine according to this example, but what should it return? The size of the internal vector, the internal data member of the course class. So if you look at the solution here, that's what we have. We have a vector of strings and a string name as data members. Default constructor, the secondary constructor. You could do a default and avoid having to write 2. You can just write 1. but you didn't have to do that. Set name here, add students. You have to do a range-based for loop over it and add each individual one. This just gets the internal variable students, and this one just returns the size. And that's what I was expecting you to do. Any questions on question 2? Okay. Question 3. So more people than I expected got this one. I was happy. So the idea here was to, you don't know so that's another thing. Many people assume that the list was in order 1 through n, even though it says not necessarily in this order. Okay? So it says it's not in this order, so don't assume that it is. So here is just finding a missing value. So a lot of people realize, well, just add up all of the possible values that should be there and subtract everything that is in the array. Just subtract everything that is in the array, and then you're left with the single value that's not there. Another idea is to loop through all possible values, 1 through n, and see, is 1 in the array by looping over it? Then is 2 in the array? Is 3 in the array? All the way through. And then when one of them says, oh, it's not there, now you know what the value is. So there are multiple ways to approach this. This was a slicker approach, but there's a brute force approach you can take too. And you can use the product of the elements. I think one student did that. So you didn't have to use just plus here. You can do times also. For peak, a lot of people noted that incorrectly that there's only one peak and it's the maximum value in the array. So if you have 1, 3, 1, 4, 1, is 3 a peak? 1, 3, 1, is that a peak? Yeah, because it's bigger than its neighbors. But is it the largest value? 1, 3, 1, 4, 1. Is 3 the largest value? No. So the largest value is a peak. It always will be, but it's not necessarily the only one. So here, what I expected you to do is to look at the directions. So here, you have to put them in sorted order, and you can't use sorting algorithms. So the idea here is, well, there are 3 cases. One, which is just a general index in the middle. One case where the index is right at the beginning of the array. And the other case when it's the very end of the array. So, or vector. So here what you do is, well, if 0 is a peak, then add that one first. Then look at the general case in the middle, not the end one yet. Look at the one in the middle, the ones in the middle. If they are peaks, add them. If we look at the last one, if it's a peak, add it too. And then all you do at the end is just print them because you added them in sorted order. Technically here you don't have to use vector of ints, so I'm just showing a solution where you do use it, but you don't have to use it if you don't want to. Like for all these pushbacks, you can just see out the corresponding index. But a lot of people just went to the general case and ignored the other 2 cases. So yeah, so I'm expecting you to, so what do you think my advice is? Read the directions because they're to help. They're not here to confuse you. Okay. Any questions on question 3, either part? Okay, question 4a. This ended up being a lot harder than I thought it was going to be. So if you wrote anything for 4a, I gave you full points. So what I thought the solution was, so this is actually wrong. I need to fix this. For here, for A calls B and B calls A, I thought that you needed both prototypes to write them because they call each other. How many do you actually need? 1. So that was my fault here in the solution. So the true answer is actually 2. but it really depends on the order that you have the functions and which one's at the bottom, which one's next, which one's next. The true answer is 2. I forget which ones they are. I think they are B and D. I'm not sure, but I'll have to check that. When it says B may possibly call D, you still need to write the prototype for it. Yeah.
Can you get extra credit points for this problem if you got everything completely right?
No, because there's no extra credit on this question. Other questions on 4A? Okay, 4B. Yeah, sorry about the typo. Well, not typo, but lack of this line in the test. This was meant to be there. If I screwed up your grading and you wrote that the using namespace STD is not there, and I didn't give you full points on that, just bring it to me. I'll fix that. But the idea here is that the input vector isn't necessarily tied to the integer that's passed in, the other parameter. Is length right here necessarily the same length as the vector that was passed in, length? No. So could I very well say process user input and I pass in a vector of 2 elements and I have length be 3? Could I do that?
Yeah.
Yeah. The compiler's not going to say, well, you called this thing length and it's not the length of the input that you passed in. I don't think the compiler's going to do that. So, but think about this for a second. Maybe if we have, say, 100 strings that we pass in on the input, but we only want to process the first 50 of them. So I could say, pass in the 100 length vector, and then have length be 50. Is that okay? So maybe this function says, process the first length number of user inputs and ignore the rest. Well, I can't just say, well, I'm going to ignore the length parameter now and have this upper bound right here be input.size, which would technically be the right way to do it. But it's going to ignore that other parameter. And we can't change the number of parameters here because then the user's code is not going to compile because it'll have a different number of arguments. So what is a better idea? The better idea is to say, well, if length is larger than the size that we want, then clamp it down to the size of our vector. So you could just say here, well, I'm going to have this upper bound be the minimum of the length that was passed in and the size of the vector. So that was a simple fix. There are other fixes that you can do. So yeah, and I go over this. Another way you can do this is because the square bracket operator will not cause your program to crash if you go past the end of the vector, we covered a different function that that did actually crash the program if you did that. And what was that? .at. So instead of square brackets, you can do .at, and that would be another fix because it would actually crash the program, which is what you would want.
I guess I was kind of confused on this one because we don't see the main function at all. I kind of assumed that length was assigned the input vector .size.
Yeah, but that's an assumption. Look at this here. Would the function produce the expected result for all inputs? So for every choice of a vector and an integer, does it produce the right input, the right output?
Oh, I guess I kind of.
There's actually another issue. Could I pass -1 as the length?
I mean, it wouldn't like it.
Yeah, it wouldn't like it. What would technically happen though? So it's not really that big of a deal. What would happen here if I passed in -1?
Well, every time I try to do that with a vector, it spits out like a weird error.
Well, look what happens. What is I set to initially?
0.
0. Is 0 less than -1?
No.
Is 0 less than -1?
Yes.
No.
0 less than negative. I know it's Friday, and I know you want to get out of here, but 0 is not less than -1. It actually is not so silly as you may think. if you deal with like unsigned types, that's not actually that silly. But 0 is not less than -1. So will I execute this loop at all?
No.
No, so it's not really a big deal. But what would be a fix for that case?
Just set it as constant. Or-
No, not allow for negatives to be passed in.
Yeah.
Make it unsigned. So unsigned would be another fix for this. Okay, any questions about 4A or 4B? Question 5. So some people did get this. I was happy about that. So I'm not going to go through the entire code. I'll welcome you to do that. But the idea is, well, if B is a subsequence of A, does that mean that every element of B has to be an A?
Oh, wait, yeah.
Yes,
Sorry.
it has to be an A. There's the issue about ordering, but every element of B has to be an A somewhere. So what you do is say, well, for every element in B, I'm going to search for it in A. And if I can't find it, then there's no way that it could be a subsequence. So we'd have to handle the issue about ordering, but that's what the outer loop is for. Every element of B has to be an A somewhere. So the index in A thing says, I'm looking at where I'm currently looking for this next element. So I'm going to start at 0, I'm going to traverse until I find the first element, and I'm going to maintain where I were last time. And then the next time through, I'm going to start at the next index, and then march from there, not 0, until I find the second element. If I find it, great. Start at the next index and march on through. So that's exactly what happens here. And then if at some point we go past the end of A before we have found B, then, before we found this element in that we want to find, then it can't be a subsequence because we're still looking for it and we've exhausted all of A. So therefore it can't be a subsequence. So this is basically just keep going until you find it. And then once you find it, move over one position. And that's it. And then at the end, we just print, is it a subsequence? Okay, so then, here I just assume that it is a subsequence until I'm proven otherwise, until I run past the end of A, and then I'm done. Any questions about question 5? Okay, so I posted quite a few things here. So solutions, we just went over those. So because of the, I'm trying to find an adjective that's not terrible. Because of the performance on midterm 2, I'm going to be giving a supplement test on next Friday. So April 5th. So here, I'm going to have questions similar to those on the midterm, on midterm 2, but all of the points here will be completely bonus points. So this test is completely optional. You do not have to take it. But if you want to take it, you're absolutely welcome to do so. I haven't worked out the details, but it's probably going to be 50 points of bonus potential there. And so it's just going to be coding questions, just like the ones on the midterm. Yeah.
So if you take it, it can't hurt us.
It can't hurt you. No, it's entirely bonus points. So it's only here to help you. Okay. So yeah, but they're going to be questions like the midterm. They're not going to be any easier. They're not going to be harder either. But I'm not going to make it any easier. So what do you think I'm asking? What should you do between now and next Friday?
Figure out what you got wrong.
Figure out where you missed and what solutions should you look at?
Solutions for midterm 2.
Solutions for midterm 2. See why you missed points. Okay? Okay, so that's that. The final exam will, so here's the final exam, will consist of only multiple choice questions. No coding. Oh, did you have a question?
I was just wondering, are you going to add the points onto this test, or is it going to be like its own?
So I haven't decided. What I'm probably going to do is I'm just going to add them to the score that you got, just directly. Yeah, that's what I'm probably going to do. What, sorry?
Will
No, so there's no cap. So if it could cause you to get over 100%, you keep all the points. Yep. Yeah. So finals multiple choice only, no coding questions of any kind. Written coding, by that I mean. So there are 250 points on the final. 55 questions times 5 points each is 275 points. So there's 25 points of extra credit on the final. So someone asked me earlier, like, what type of questions should we expect on the final because it's so different than what we've seen? So what do you think I'm going to ask? I'll let you try to figure out. What questions should I ask on the final? Yeah.
Will this compile?
Will this compile? And by that you mean I present a code segment and then I ask a question about it. Yeah, so that can be one. What's another one? Yeah.
Kind of like saying, you give us like kind of like a scenario and just like show us what option would be best. Is that kind of what we're going to do?
That's perfect. Yeah.
What will take up the least amount of space in your drive or whatever?
I don't think we really have dealt with that. Maybe,
Like
but
shortest code, I guess, like is similar to.
maybe, possibly. But we haven't really covered that, so it's not that big of a deal as the other two things. Do you had one?
What will be the output?
What's there?
What will be the output?
What is the output of this code? Yeah. So what I'm trying to ask you is, if you're going to be using programming in the real world, or even if you're not, you're presented with a scenario. What technique should you use to solve this problem? So it's not unique to programming, but the questions, of course, will be about programming. But you're presented a scenario, and you have to figure out what techniques should you use. So as an example, like let's say that you are processing user input, but you need the input to be in sorted order. And let's say that you're doing this many lookups on this length of list. What should you do? Should you just use linear search every single time? Or should you sort it once and then do a lookup using binary search? So that type of question is something that would be reasonable to ask in, like, if you're going to be using real programming here. So another one would be, here's a code snippet from that maybe was thrown at you that you need to understand quickly. Could you figure out what this code does? So you have this C++ code segment. What's the output of it? So it's things that would be actually a real application of understanding how the concepts are put together. So if you see vector of string, you should know what that corresponds to. If you see a range-based for loop, you know what that's supposed to do. So if you know what an off by one error is there an off by one error in this code? Things like that. Those are the things that matter. Not like what does the keyword static mean? Like regurgitating information like that. That's not helpful. What is helpful is understanding, here's a situation, what should you do to solve this problem? Okay? So those are the questions I like asking. And the ones that you should expect on the final. Okay? Yeah. Yes. Yes. So the entire final exam is cumulative. So what I like doing is I try to have the questions be uniformly weighted. So just as much stuff on the intro slides as much as the stuff on loops or arrays or whatever. So I try to make it as uniform as possible. It's not like I'm testing a lot on the later material and nothing on the earlier stuff, because the earlier stuff is important too. Yeah.
Will the questions be in order for how we learn them, or just all randomized?
I'm guessing they'll be in order, but I haven't made the test yet. So we have 3 weeks, I think. Yeah.
So we're going to be expecting stuff like the hardware, software,
Yeah.
like that stuff too.
Yeah, you should expect a few questions on those, a few questions on just C++, a few questions on, so let's actually look. Few questions on C++, few on decisions, few on loops. You get the idea. Yeah, so, and I try to make it the same number in each. Yeah. Other questions about the final? Yeah.
Are we allowed to bring a sheet of notes?
Mhm. Yeah, so just like both midterms, you can bring a sheet of notes just like before. Mhm. Yeah, and I'll talk about like how you input the multiple choice answers, all that stuff at some point. But I haven't made the test yet, so. Other questions? Okay, so we're actually a little behind, so let's actually get back to material. So what have we been talking about before the midterm? Searching and sorting. So searching is obviously useful, but why is sorting here?
Because we need to sort in order to use binary search.
Ah, because binary search is better than linear search. Did I just commit an atrocity there?
Kind of.
Yeah. So what was wrong with my statement?
Because it's not always true.
It's not always true. And how did we show that? By actually implementing it and testing how long it actually takes. So for lists long enough, yeah, binary search is better. So there is a motivation to sort, of course. So we talked about various types of searches. Linear search, just look through the entire list. No issue there. And it's easy to implement. And you can just use a range-based for loop for it. And the elements can be in any order. But if the list is long, that's really slow. So binary search is, I assume what about the list?
That it's sorted.
That it's sorted, either ascending or descending. Let's assume ascending. Then what you do is you go to the middle of the array. Am I looking at the middle value or the middle index? The middle, I almost committed an atrocity. Middle index, right? Because could the middle value be way at the beginning or way at the end?
Oh, yeah, I see. Middle
Yeah,
index.
so we would have to find the middle value first to find where the middle value is. So cut the list in half, so middle index. Then if it's equal to the thing that you're looking for, great. If not, well, if it's less than the thing you're looking for, then the thing that you're looking for cannot be in the first half of the list because it's greater than the thing you just looked up. So you only search half of the list. And we'll go over code of how to do this. So as an example, if we're looking for the value 7, we look at the middle index, which is 11 and has the value 11 in this case. Then we ignore the second half of the list because 7 is less than 11. And then we look at the first half of the list and keep going until some condition happens, and we'll see that in a second. So binary search is obviously better for long lists because I cut half of the list away every single time. It turns out that if you have 20,000 elements, you only need to do 15 searches on average, which is really nice compared to roughly half of them for linear search, because you search half of the list on average. But of course, it requires the elements in order, to be in order. Okay, so I'll post this code that I'm going to show you, but I just want to bring it up here. So this code right here is, I guess, a complicated way of doing doing linear search. So all it does here is, while the index is less than so they're using normal arrays here, which is why there's no like dot size or whatever. So here it's just saying, while the index is still valid within the size of the array that was given to us, if we found the value, it's right at the index we're looking at, great, we found it. And then we set the position to be wherever we just found it. But if we didn't, then we increment the index and then check again. And then we return the index at which we found it. But here's the thing. What if we never find it? So we return position at some point. Let's just say we never find it. So the value's not there. What am I returning? -1. Because why? I never set position to anything other than -1. So that means that if the thing is not there, this function will return -1, which is the actual convention of how these functions sometimes work. -1 usually means that we didn't find it, and anything else means that we did find it. What's a better way to do this, to tell you that we did find it or didn't find it? Yeah, use a bool. So here, instead, you could just say return true, that it is there. And then down here, we say return false. So false and true are a lot more communicative of what actually happened than -1 or not -1. The second example here, so this code is, I'll give you this code, but it shouldn't be that hard to make better. So I would actually use a range-based for loop here instead of this while loop. Let's look at the binary search example. So here, we got some code up here that does all the setup. We don't have to really worry about that. We're assuming that array is sorted right here. So here's the meat of the thing. So we're going to maintain two indices, a first index and a last index, okay? So at the beginning, first is going to be the very first index, and last is going to be the very last valid index. But then they're going to change as we go along. Ignore the condition for now. What we do first is say, we're going to find the middle index of the two, which is compute the average of the two. Add them up, divide by 2. So that's some middle index. If we found it, then is the value in the list? Yeah, so if we found it, did we find it?
Yeah.
Yes, good. So that means we found it, and the position where it is that index. If the thing that we're searching for, which is value right here, is smaller than the index we're just looking at, should I look in the first half of the list or in the second half of the list? The first half. Why? Because it's smaller than the middle element, which means that what do we know about the array? Is it in ascending order or descending order? Ascending order. Good. So then we search the first half, and the way we do that is say, well, should I change the first index? Should I change the second index? Yeah, I want the second index to be the last valid index. That could be possible. And in this case, well, could it be the middle index that we just looked at and we determined it was not equal to it? Could that be a valid index to look at?
Could be, but it would be wasteful.
It'd be wasteful. So what we do here is we do middle -1. So instead of looking at the thing we just looked at and we determined it wasn't that position, we do -1. And then set the second pointer, the last index, to be the middle -1. But otherwise, what does this else correspond to at the end? If it's not equal to the thing we're searching for, and it's not less than the thing we're searching, it's not greater than the thing we're searching for, what is the other possibility? It's in the second half of the list. So which index should I move? Should I move the last one, or should I move the first one? Move the first one to middle +1. So because I don't want to have to search middle again. So I make it the first index to be middle +1. And then we go back and we check again. If we haven't found it, and some other condition I'll get to in a second. And then we check that half of the list. And then we move one of the pointers, as the case may be. And then we check that quarter, then that eighth, that 16th, all the way until something happens. What do you think this condition is for?
Make sure you don't switch the indices.
Well, first at every single iteration is going to be less than or equal to the second index, the last index. Well, could they be the exact same index?
If they are ever the same index, then you're
Yeah.
done searching.
Well, if they're the same index, then it better be at that index, whatever it is. Well, if it's not there, if it's not at the same index, the first and last being the same, then what's going to happen? One of the two is going to either move one down or the other one's going to move up by one. And what just happened to the values of the first and last index? They swap positions. So the first index is now larger than the last index. So the first is larger than the last. Does that make sense? Well, the concept should make sense, but should those indices ever be in that order? No. So that's why the condition first less than or equal to last is here. As long as the indices are in the right order, keep searching. If you have it ever be that they're in the wrong order, then there's no way that you could have found the element. At every single iteration, you never found it, which means it can't be in the list. And then we return the position of wherever it was. So I'm going to post all this code for you so that you can actually look at this. I'm not actually going to give bonus points for this, but there's actually a bug in this code. For a very small number of instances, there's a bug in this code. Does anyone know why?
Well, if it goes through and it doesn't find like the value, it just returns the middle position. It doesn't.
No, the logic is correct. So position will always be -1 until you found it.
Oh,
Yeah, so that's correct. So the reason is it has to do with this line right here. What if we had an array with many elements in it, billions of elements? Well, what if like first plus last is larger than the largest possible integer that could be represented? So if like the largest integer, say, is like 2 billion or something, what if like first is 1.5 billion and last is also 1.5 billion? What is 1.5 plus 1.5 billion? 3 billion. Is that larger than the largest possible integer? Yeah. So what'll happen here is, remember PEMDAS. The things in the parentheses will be calculated first, which means that this will underflow to a large negative value. So this code is actually not correct, in that you could have an error here in that middle could be a negative value. So I invite you to figure out, well, how would you actually fix this?
you would divide each one individually by 2.
That'd be one idea. To divide first by 2 and then add last divided by 2. That would be a way to get around it. But it won't be actually the exact same value every single time. Because what if first and last are both odd? Then first plus last is even, and then that's okay. But first divided by 2 is odd, then you round down. And then last divided by 2 is also, you'll round down. So you round it down twice. And so you won't get the same value every single time. So I invite you to figure out how would you actually fix this, because if you really wanted to make this correct, what would you do? Yeah. Well, I still need to do this addition to find out the middle value in between.
Then you can just, so you, instead of like, it being a number, it's just like each like place is a single character, and then you would like add the values.
Yeah, but characters are still represented by integers. So that won't necessarily work.
Well, you would only have one value, so if you want to do 100, it'd be like 1, like a char string,
So how would you represent 2 billion?
2 billion, so it'd be like a 2 and then the 6 zeros.
Yeah, but I still need to actually do the addition to find the average of the two values somehow.
But then, so then you like add the corresponding.
Yeah, so you are correct. There are things called big ints that do that sort of thing, where you actually do the exact representation, not with one integer, but many of them, or as a string, as the case may be. And then that does work, but it's really slow in comparison, because you have to actually look at each individual character and do an addition that way, instead of just doing it in one swoop. Okay, I'll see you all on Monday.